Solving absolute value inequalities is a lot like solving absolute value equations. The main difference is that rather than having an equal sign, we're going to be looking at a greater than or less than sign. It's going to be, again, really important for you to read the problem in terms of words to figure out whether it's asking you if the distance is less than, which is going to imply a conjunction, or greater than, which is going to imply a disjunction. So let's take a look at an example. In words, what this says is the absolute value is less than 3. So in other words, the distance on the number line is less than 3. It may help you again to draw a number line and to take a look at where on the number line the distance falls less than 3. So notice what I did. Basically, what I looked at is that anywhere from 0 to 3, the distance is going to be less than 3. And on the other side, anywhere between -3 and 0, the distance is also going to fall less than 3. Because anywhere here that I take a spot, I take a point, if I take that absolute value, it comes out as the positive number and it's something smaller than 3. So the less than sign implies that we have a conjunction. And we can set up this problem like this. X falls between -3 and 3. So that's our range of possible answers is anywhere between those two. So again, we're going to still use the same policies that we had before. When it's less than or greater than, we use parentheses in our interval notation. If it has an equals to underneath it, we'll use brackets. So the range of acceptable answers here is -3 to 3, not including the endpoints. So let's take a look at something with a greater than sign. So, whoops, forgot the absolute value signs. So here, what's happening is, again, thinking about this in words, it's telling us that the distance is greater than 2. So it falls further away than 2 spots on the number line. So again, drawing a picture might help. And basically, we're looking for where is it more than 2 spots away from 0. It's going to be more than 2 spots away, going this way. And that's an open circle here. And it's also more than 2 spots from 0 anywhere over this side. So, just like when we had a disjunction before, the greater than sign here implies a disjunction. It implies that we have 2 intervals that will satisfy this. And again, if you want to check your answers, just choose a point within the interval we've defined. So for example, -5. If I plug it into my inequality, the absolute value of -5 is 5, and 5 is greater than 2. So if I've chosen correctly, when I go to check my work, I should get an acceptable answer. So the next part of this is, again, write the intervals. So this way, starts at 2, parenthesis, goes to infinity. On the other side, remember our smaller number is on the left, larger number is on the right. This arrow is going from -infinity to 2. So our answer to this inequality, we can look at it like this. It breaks in 2 parts. X is greater than 2, which we represented with that interval, 2 to infinity, or x is less than -2, which we have represented by that interval there. So both parts are what you need to have for your answer. So let's try something a little more complicated. So again, think about this in words. This is asking us, where is the distance less than -5? Less than implies a conjunction, and it tells us that this expression is going to fall between 5 and -5 on the number line. And I didn't draw the number line this time, but remember, drawing it may help you to visualize what's going on. So once I have it set up like this, it solves the way that a conjunction solved before in our previous lesson. We're going to start by subtracting 3, and what we do to the middle, we do to both sides. Then we're going to divide by -2. The same rules of inequality still apply. When you multiply or divide by a negative, you reverse the inequality signs. And so we find that t ranges between -1, it says t is greater than -1, and also it's less than 4. So we write our interval, smaller number on the left, larger number on the right. The range of acceptable answers is -1 to 4. And again, if you want to check it, choose a value between those two numbers. For example, 0, and let's plug it in. 2 times 0 is 0. 3 minus 0 is 3. The absolute value of 3 is 3. 3 is less than 5. So it works. Anything we choose in there is going to work out. So we'll do something a little more complicated now. Okay, so in a problem like this, before we can do any work with setting up our absolute value, we need to get the absolute value alone on one side, which means that we've got to get rid of this 3. It's going to mess everything up if we leave it here. So we start by subtracting 3. And that leaves us with the distance from 0 is greater than or equal to 5. Greater than implies a disjunction. So we're going to set up two intervals. One of them reads basically as it is. This is greater than or equal to 5. The other side must be less than or equal to -5. Remember, draw a number line. If you start to get confused, we're looking for the two places that are further away from 5 on the number line. So now that we have our two intervals, we go ahead and solve them. Add 1 to both sides. So on this side, z is less than or equal to -2. Remember that the inequality sign is pointing towards the infinity. So we have from -infinity to -2, and we have a bracket because of the equal to underneath there. On the other side, z is greater than or equal to 6. Divide by 2. Z is greater than or equal to 3. Again, bracket, 3 to infinity. So these are my two intervals that are going to satisfy this inequality. And again, if you want to check your work, choose a value and plug it in. So let's try -3, for example. -3 here would give us 2 times -3 is -6. Take away 1 is -7. The absolute value is +7. Then add 3 is 10. 10 is greater than or equal to 8. So this interval, it works. Let's try the other one. We'll choose 4. 2 times 4 is 8. Minus 1 is 7. Absolute value is 7. 7 plus 3 is 10. 10 is greater than or equal to 8. So we just checked both intervals and they both work. So that is our answer. And don't forget that we can put an or there because all we care about is where is there at least one line. It can be here or here. It can't be in both places at the same time. So at this point, you've got enough information to get started on trying to solve inequalities. Don't worry if this gets a little bit challenging for you. It really just takes practice, and feel free to ask questions.